There are three major types of machine learning: supervised, unsupervised, and reinforcement. Supervised learning refers to the case where we provide the algorithm with inputs and their corresponding desired outputs. Based on this information, it learns how to produce outputs as close to the ones we are looking for. Both examples, the one about the weather forecast and the one about preparing coffee, illustrated supervised learning. That was intentional, as it is the focus of this course. Alright. The second type of machine learning is unsupervised learning. In unsupervised learning, we feed inputs, but there are no target outputs. This means we don't tell the algorithm exactly what our goal is. Instead, we ask it to find some sort of dependence or underlying logic in the data provided. For instance, imagine we administrate the website catsanddoggos.com. Users have the option to submit photos of their cats or dogs to the website. Once a photo has been submitted, we would like it to be automatically classified in the subpage cats or the subpage dogs. In supervised learning, we would train the algorithm on a dataset of, say, 1,000 cat photos and 1,000 dog photos. Each would be labeled cat or dog. The model would then learn how to interpret an input picture as either a cat or a dog, minimizing mismatches over the training set. Sometimes, however, we may not have the resources or the need to label the whole dataset. In the previous dataset, there was a person who manually labeled all 2,000 pictures. Now, imagine a dataset of 2 million pictures. If it takes a person 5 seconds to label a picture, a dataset of 2 million observations would take around 2,800 hours or 345 working days to label all pictures. With unsupervised learning, though, we can train the algorithm without labeling the photos or in an unsupervised way. We could simply ask it to split them into two groups based on visual similarities. The result would be two groups that are unlabeled. Once we have obtained that, we can examine them and say, "Oh yes, the first set is dogs and the second set is cats. Thanks, algorithm." Unsupervised learning is especially useful when our goal is to split a dataset into a certain number of categories, which we do not know prior to implementing it. That, by the way, is called clustering. Okay, the final type of machine learning is reinforcement learning. Without digging too deep into it, with reinforcement learning, we would train a model to act in an environment based on the rewards it receives. It is much like training your pet and rewarding it with treats every time it achieves a goal, sits, rolls over, or gives you a pawn. In the same way, the machine learning algorithm could be taught how to play Super Mario by rewarding it for progressing with an increase in score. Alright. Supervised learning is the focus of this course. That is because it is the simplest and most commonly used. To exhaust the topic, supervised learning could be divided into additional subtypes: classification and regression. The difference is very straightforward. Classification supervised learning models provide outputs, which are categories, such as cats or dogs. In regression supervised learning models, the outputs will be of numerical type. For instance, predicting the euro-dollar exchange rate will always give us a continuous number, like 1.21 or 1.19. In this course, we will create both classification and regression algorithms. Stick around, and thanks for watching.